Assalamualaikum. Hi, we are from Group 2. We're going to represent our GBI project, which is Eco International School. My name is Abdul Wafi bin Munawar.
Hi, my name is Nur Amira Wahida binti Husnazri.
Hi, my name is Nur Izzati Elena binti Aziman.
Hi, my name is Nur Shahira binti Rasid.
The proposed location of Eco International School is at Persiaran Kasia Selatan, Batu Kawan, Pening. This neighborhood is ideal because it has a great demand for educational facilities, which can be determined by looking at the populations, age groups, income levels, and educational backgrounds of the residents. To accommodate all the facilities that should be near the school, this school was built 9-story high. Within a 5 km radius, diverse land uses like restaurants, malls, farms, residences, and factories surround the site. This proximity helps students living close by to easily get to school. Also, it makes it convenient for parents who work nearby to send their kids to school without any hassles. The variety of nearby land uses brings numerous public facilities within a 3 km radius, such as stadiums, malls, clinics, police stations, and more. Also, existing infrastructures from road to utilities cut down construction costs significantly, offering a substantial advantage. GBI, by the Association of Consulting Engineers Malaysia and the Malaysian Institute of Architects, aims for sustainable construction. Certification marks the beginning, but the post-certification would sustain eco-features through constant upkeep, audits, and upgrades. Eco International School scored 88 points, achieving platinum grade for lasting environmental impact. This is because we scored 30 for energy efficiency, 18 for indoor environmental quality, 13 for sustainable site planning and management, 10 for materials and resources, 10 for water efficiency, and lastly, 7 for innovation.
For energy efficiency EE, we will install LED lighting. LED converts a larger percentage of power into light when compared to conventional lighting sources. To achieve the same brightness, they use a great deal less energy. It is because to provide the same quantity of light, LED needs 75 to 80% less energy than incandescent bulbs on average. LED light also produce extremely little heat in contrast to incandescent bulbs, which release a significant amount of energy as heat. LED also have a longer lifespan, which lowers the need for replacement. Another example of EE that we implement in this school is utilizing double glazed window and an electrical submetering system, solar panels, motion-activated smart lighting, high-performance HVAC system, automated timer system, and regular inspection. Next, for indoor environmental quality (EQ), we will utilize smart glass. It can be used to automatically adjust the tint based on the degree of sunlight. Smart glass can reduce the energy consumptions of buildings by regulating the amount of solar heat gain and natural light entering indoor space. It will also provide thermal comfort and lighting conditions for the occupants. Smart glass also offers privacy and security features for the occupants by switching from transparent to opaque mode. Other examples of EQ that we implement in this school are utilizing awning windows, smoke or fire detectors, CO2 monitoring system, low VOC paint, acoustic walls, thermostats, regular maintenance, and latch opening. For Sustainable Site Planning and Management (SM), this school will implement the Industrialized Building System (IBS) during construction works. IBS focuses on making building parts in a factory using the same methods. This is in line with the classic system, which needs to rate the work quality of the building. IBS reduce error rates by fabricating buildings components such as beam, column, wall, etc. in the factory, and this implies fewer mistakes happen on sites. As IBS functions similarly to an assembly line, it speeds up construction and lower expenses. Building sites are quicker and produce less waste when IBS is used. Other examples of SM that we implement in this school are choosing a site with good feasibility study, near the basic facilities and with flat topography, minimizing the building footprint, implementing IBS system, providing a clear signage at the site, using an electric vehicle, sufficient parking, detention pond and building's roof are partially covered with plan.
For materials and resources part, we're using the recycled concrete aggregate. It is a material that is made from used concrete that has been crushed and separated from the mortar. It will reduce the consumption of natural aggregate, which cause the environmental damage due to excessive mining and quarrying. It also improves the performance and durability of the concrete as it can provide higher strength, lower shrinkage, and better resistance to chloride penetration and carbonation. Other than RCA, we also reusing the formwork, using aluminium foil for roof insulation and provide recycle bins. For water efficiency part, the toilets are equipped with dual flush system and automatic sensor faucet. The user can choose between two flush options, one with bigger capacity for solid waste and the other one with a lesser volume for liquid waste. Compared to the traditional toilets, which have fixed flush volume for each use, this flexibility lowers the total water use. The result will be cheaper water cost since it consumes less water per flush. Other than that, the automatic faucet can reduce the total utilization by up to 30% to 50%. It requires less maintenance compared to conventional faucet. And the last part for the innovation, our group will use the automated car park lift. When the car arrives at the entrance, the video camera will capture the image of license plate and assign a parking space. The driver leaves the car and scans the QR code. Then the car leaves by a platform and moves to the allocated parking space. The car is securely parked and the system records the time and the duration of the parking. When the driver returns, the QR code needs to be scanned again at the entrance to initiate the retrieval process. The car is left by the platform and moved back to the exit route where the driver can collect the car. It provides a high level of security and safety by preventing unauthorized access and theft of vehicles. It also avoids accident and damage caused by human error and vandalism. It can lower the operational and maintenance costs by using less energy and resources than conventional parking system, by minimizing the wear and tear of the vehicle and parking structures.
Green building certified by GBI cost more at the beginning because they need special materials and advanced technologies. These eco-friendly things need more money upfront and expert to set them up. This makes clients worry about the initial cost. To cover GBI certification costs, a smart plan showing long-term gains by calculating ROI is important. Also, using tax benefits, subsidies like Green Investment Tax Allowance, and financing scheme like Green Technology Financing Scheme make it easier to afford and encourage using GBI. Architects aiming for GBI face a challenge balancing sustainability and aesthetic. For instance, creating a school with wide glass facades for a futuristic look clashes with energy efficiency goals, illustrating the struggles between balancing aesthetic and sustainability. Therefore, collaboration among architects, engineers, experts, and clients from project onset foster a balance between design and environmental responsibility. For instance, solutions like double glazing or glare control maintain aesthetic while enhancing energy efficiency in scenarios like extensive glass facades. Civil engineers adhering to GBI standards face a clash between traditional swift construction methods and sustainable site design. GBI's documentation and evaluation process conflict with speedy construction, leading to potential project delays. Other than that, extensive excavation clash with GBI focus on minimal site disruption and ecological conservation. As a solution, CNS can incorporate advanced construction methods like prefabrication to minimize site disruption and speed up timelines. Also, continuous education in green techniques ensure compliance without compromising qualities or timelines.
The problems for M&E engineer is optimal performance and compatibility with sustainability goals, flexibility of location, limited accessibility, and a longer lead time. And for their solutions is collaborating with specialists, forming partnership with manufacturers, building a robust industry network fosters knowledge exchange, and the last one is continuous research and staying updated. And the problems for quantity surveyor is lack of consistent data, requires specialized knowledge to calculate ROI, and the last one is client does not see the profit of implementing GBI. So for the solutions is creating extensive database or storage, working with industry organization, using advanced tools or software, and the last one is remaining up to date on a new sustainable practices. Return on investment. This is a crucial factor in green building. While initial cost can be higher, the ROI is realized over the time through the significant savings and the benefits. Green Building Index. Green buildings are often certified by the standards like the GBI. GBI certified buildings can yield the energy savings of 30% up to 40% compared to the average buildings. Market value. Green buildings can have a higher market value and attract tenants and the buyers who value sustainability, enhancing the ROI. Environmental and social returns. When considering the ROI for the green buildings, it is important to consider not just the financial returns, but also the environmental and the social returns. Cost of sustainability design. Designing a sustainable school building using the green construction features can be expensive, but every component of the structure supports environmentally friendly products. So for the total investment cost is 1,268,200 Malaysian ringgit. For the total maintenance per year is 93,200 Malaysian ringgit. And for the total saving per year is 151,500 Malaysian ringgit. For the sample calculation in year 3, the calculated percentage return on investment is negative 90.81%. This was derived from the formula which consider the earning minus expenses added to net earnings before division by the total investment cost and all multiplied by the 100%. And the project become profitable on the 23rd year. For the conclusion, the Eco International School is leading the way in innovative construction, aiming to reduce climate change impacts by using renewable energy and resources. The school not only meets demand but also exceeds the advanced green building construction standards of Batu Kawan City and Malaysia. The school achieved a platinum rating in the GBI by scoring 88 points, indicating excellent practice. Despite initial negative returns, the project became profitable on the 23rd year with a ROI of positive 1.14%. The Eco International School offers a valuable learning opportunity in all areas, including green building and construction management. That's all from me. Thank you.